Hello everyone, welcome to the session. In this session, I would like to discuss about free space management of operating system course. So we'll see what is free space management. In the previous sessions while discussing about file system, we just learned that file system is generally stored in the secondary storage device like disk. Now the thing is, when you're referring to secondary storage like disk, we learned that file is stored in terms of blocks in the disk blocks. When you're storing the file, you should know how many disk blocks are available for storing your file and what at what locations. So we have seen some allocation and access methods. Now here we are just seeing how to manage them. So basically this free space management system keeps track of free disk blocks for allocating space to files when they are created. So it will just keep track how many blocks are free, how many are released, how many are not yet released, likewise. So why it is doing so means to reuse the space released from deleting the files. Free space management becomes crucial. Now the system maintains a free space list which keeps track of disk blocks that are not allocated to some file or directory. So on the whole, it maintains a set of or a collection of free disk blocks so that it can be allocated to some other file which is created just now. Now this free space management will be actually implemented by four methods. One is bitmap or bitvector. Next one is linked list. Third one is counting. Fourth one is grouping. Now let's see what are these four in detail. The first one is called as bitmap or bitvector method. So from the name we can guess to some extent that it is a method which is basically implemented using bitvector. So bit vector is a series of collection of bits where each bit corresponds to a disk block. Now in that, if 0 is indicated, then that block is not free. It is allocated to some other process. And 1 indicates a free block. So for example, I'll show you here. This is a diagram where it has 16 blocks here. Now, if you'll observe, out of all the 16 blocks, some are in colored one, some are in normal white color. The colored one indicates that they are already occupied, and the white colored one defines that they are not occupied. Now, to represent this all 16 blocks about their status, whether they are occupied or not, I'll be using bitmap or bit vector method. In that, the bits will be written in this fashion. Either zeros or ones. Zeros indicates that the block is occupied. Now just observe, block 1 is there, which is actually occupied. So that's why I wrote 0. Similarly, block 2, 3, 4. So first 4 blocks are occupied. That's why they are zeros. And the next 3 blocks, that is 5, 6, 7 are free. That's why their number is indicated as ones. So likewise, using this bit vector method, we can easily identify which blocks are free and which blocks are occupied. So it just used two values, zeros and ones. 0 is used to allocate that block is already allocated to some file. 1 indicates a free block. Now every time when you want to refer to particular free blocks, then you just need to have an instance of this bit vector of disk block. So by that you can find out easily which block is free. Now the major advantage of this method is it is very simple to implement, because only thing is you have to maintain the bit vector, a bit value for every block. Next thing is finding the first free block is efficient. So in this method, finding the first free block is efficient. So how it is found? It's basically found with a formula. Just see here. It requires scanning the words of 8 bits in a bitmap for a non-zero word. A zero, that is a non-zero word means which doesn't contain all zeros. Now the first free block is then found by scanning the first bit in the non-zero word. Now I'll just give you one example of this so that it will be clear. Now the formula that is used to find out the first free block is this one. The one in red color. Now just observe number of bits per word into number of zero values words plus offset of first bit in the non-zero word. Now let's see this. Let's apply this formula to this this example. Now, number of first parameter is what? Number of bits per word. So, how many bits you are taking it per word means we'll take 8 bits. So, I am taking it as 8. So, 8 into number of zero value words. So, actually, when we'll divide it into 8-bit words, how many words will get? We'll get 2. So, one word is this, one word is this. And out of these two, which one is non-zero? Means, sorry, which one is zero valued words? Means completely zero. So neither the first part is completely zero nor the second part is completely zero. It means that the number of zero value words are zero. So we have seen the first parameter as number of bits per word, that is 8 bits. Next is number of zero value words are 0 plus offset of first bit 1 in the non-zero word. Offset of first bit 1 means in this entire word the first bit which is 1, at what location? It is fifth location. So offset of first bit 1 in the entire word is fifth location. So 1 2 3 4 5, fifth location it is 1. So you have to add that. Offset of bit first bit 1 in the non-zero word is 5. So apply this formula. So that is 8 into 0 plus 5. So that is how much? 5. So this indicates the first free block of your uh, location, first free block location. So I want to know where is the first free block available. So I have to find out that. I applied that formula. First of all, I have seen that how many bits are there in a word into in both the words. Here you have two words. If you have more than two words, then you can identify out of those three words which one is completely zero. So nothing is there. That's why it's 0. So 8 into 0 plus first bit which is 1 is fifth location. So I got it as 5. So it means that in all these blocks, the fifth block is the one which is first block which is free. So that is how you can easily find out the first free block. So that is what the advantage. So second advantage says that finding the first free block is efficient. Now let's see the next one, that is linked list method for finding the free disk blocks. Now let's see how it is done. So we'll see the diagram first. Now just let's see the same diagram. Now here if you'll observe, the first 4 blocks are actually occupied. Now here I have a block which is free, that is fifth block. Now from fifth block I'll maintain a linked list of all the free blocks one after the other. So the first block which is free is 5, right? So this will is called as free list head. Means from here onwards we'll be tracking the remaining free blocks. So if you'll observe, fifth block is having a pointer to the next free block, that is 6. Next 6 is having a pointer to 7, which is free. And 7 is having a pointer to the next free block, that is 14. And then 14 to 15. Likewise, every block is having a pointer to the next block which is free. So this maintenance is actually easy. Like this maintenance will make you easy to find out the next free block immediately instead of searching the entire set of blocks. So that is the main advantage. Now just see the definition. In this approach, the free disk blocks are linked together. A free block contains a pointer to the next free block. The block number of very first disk block is stored at a separate location on the disk and is also caged in the memory. So next thing, as I told, advantage is only thing is if you find the first one, remaining all automatically it will show you the remaining free blocks. That is advantage. It may have a drawback if too many free number of blocks are there. That is, too many pointers are needed to access the blocks. That may be in some cases when too many blocks are there. Now this is about linked list method of accessing free disk blocks. So this second one. Now let's see the third one. Third one is called as grouping mechanism. Now let's see what is grouping here. Grouping is nothing but imagine that let's see this example. Yeah, so this example. Now if I'll apply grouping on this one, so what it will do is it will search all the occupied blocks, then it will go to the fifth block. Now fifth block is a free block. Now what it will do is When it is free, the fifth block will have actually uh, pointers to all the remaining blocks. Now imagine that fifth block is called as an index block, so which is actually free. Now fifth block will contain the indexes to 6, 7, 14 and 15. So instead of going to 6, then 7, then 14, then 15, one after the other, you can directly go to block 5. If I'll go to block 5, directly here itself I can find out easily which blocks are actually free. So in linked list, the problem was you were searching each and every block one after the other. But here, if you'll go to this block, here itself it will tell you what are the blocks that are free. So that is called as grouping mechanism. Now imagine that if you have too many blocks and all the blocks address can't be stored in this single block. In that case, what it will do is, just imagine that it is a case, then what fifth block will do is, it will store the address of all these blocks, that 6, 7, 14, 15, and if I'll go to 15th block, 15th block will act as an index block. Now 15th block will store the addresses of remaining blocks which are actually free. Means the first block will store the addresses of all the blocks. Out of this, the last block will actually access another index block which will store the addresses of remaining blocks. So it's like a leveling, hierarchical. So that is grouping. So this is a one of the best free disk block accessing method. Just here definition. This approach stores the address of free blocks in first free block. So we have seen that it is stored in fifth block. The first free block stores the address of some, say, n free blocks. Out of these n, the first n minus 1 blocks are actually free, and the last block contains the address of next free block, free n blocks, address of next free n block. So like we have seen in this example, 15th block will store the addresses of free blocks of remaining all. Likewise. Now let's see the advantage of this one. Advantage of this approach is that the addresses of a group of free disk blocks can be found easily in one step. That's a major advantage. So this is about grouping. Next is counting. Now let's see what is counting. Counting here, what counting mechanism will do is, let's see this example again. Now in this example, now if I'll follow the counting mechanism, what it will do is, it will first find out the first free block, that is fifth block. So it will write it as 5. Then followed by how many consecutive free blocks are there, it will count that. So it will write block 5, and block 5 is followed by 2 more free blocks. So 5 comma 2. So 5 indicates the first block followed by 2 blocks which are free. Now similarly here, if you see, 14th block is free, and immediately after 14 you have one more block which is following, which is free. So here you can write 14 comma 1, means you are excluding the block which you are counting. So that is about counting. Now let's see the definition. This approach stores the address of first free disk block and a number n of free contiguous disk blocks that follow the first block. Okay, a number n of free continuous disk blocks that follow the first block. Every entry in the list would maintain address of first free disk block and a number n. So example I'll show here. Address of block 5 comma 2. So what is address of block 5 means? That is the first block which is free. So address of block 5, that is the first block which is free, comma 2. So as I told, 2 means it after 5, 2 blocks consecutively are free. Likewise you can mention. So this is another method of maintaining free disk blocks. So this is about free space management. Let's see, recall what we have learned. So we have seen that free space management is nothing but keeping track of all the disk blocks which are free, so that you can be allocated for another files which are created just now. So you have to know how many are free, how many are allocated. If something is not releasing the blocks, you have to get it released. Now to keep track this free space, you are following 4 methods. One is bitmap or bit vector, next one is linked list, next counting and grouping. So bitmap will indicates with the values like zeros and ones. Zeros indicates that occupied, one indicates free. And its advantages are simple to understand, and finding the first block is efficient. Next, we have seen a linked list which has pointers to each other which are free. Advantage is very easy, just need to find out the first block, remaining all will be automatically detected. But the drawback is if too many free blocks are there, then pointers will make too much of overhead. Then grouping is very easy, actually it's like indexing. It's again, its advantage is finding the first one is, if you'll find the first one, then that's enough, you can find out remaining all free blocks. And the last one is counting indicates that it will tell you what block is free followed by how many blocks are consecutively free. So these are the four methods by which we can maintain free space management. So I hope everyone understood in this session. Thank you all.